Hello, Kush. I think I should start now. I have got many people joining. Hi. Can you hear me properly? Okay, nice. So let's get started then. Okay. I'll share my screen and there no presentation, mostly interview preparation related chats and questions, guidelines, majorly on that note. Okay. So let me set these things up. Jiri, yeah, this is being recorded. You can ask it from the Upgrad team. So you can get the recording from there. Okay. So just give me a moment. Let me adjust this accordingly. Yeah. Okay. So, hi, very good evening, everyone. My name is Mayuk. I'm working as software developer at Microsoft now. And with a couple of years in the past, I have majorly worked on big data, on high scale systems, on majorly on Spark, Hive, Hadoop, both kinds of SQL and NoSQL database management systems, scheduling every dimensions of a big data product on that. So in today's session, we'll have majorly focusing on the interview aspect of it. What our you guys can expect from an interview, what kind of questions are being asked, or how we should move for a certain kind of problem set, what kind of questions, and also a bit of internals of concepts. If there is some gap on there, we'll try to cover that as well. Majority of that completely on the interview preparation. There is no slide. Everything we'll discuss on based on the requirement. We'll go and take a deep dive on the things we required on that. So on the interview process, is it the first time you'll be giving interview, or like you have given some interviews earlier on big data, and this is you just started, but you have already some experience? Okay, fine. So on the big data side, when you go for any interview, the majority of the things if you see is the data, right? So if you ask, or let's say if you are to work on big data, the first thing you should know is basically what is a big data, right? In big data, there will be the 4 V's principle we have heard, or there are several other categories, various types of data. Then it goes to this is majorly in the concepts of cloud computing, I'd say, and it different kind of deployment models and the various kinds of clouds, various kinds of public cloud strategies like PaaS, SaaS, and EaaS, all such things. First, is a thing which you found forms a foundation of big data. That is a basic concept, something that is will can expect some questions of it. Definitely going to come your way. And then another big chunk of is a SQL. So when you go for SQL, there are multiple things. In SQL, there will be various queries in how you model the data on the ER diagram, and each and every minute details of this. What given a scenario, many places will see you'll be given a scenario, and based on that scenario, you have to come up a solution which will revolve around data modeling. So that will sometimes also see how you think about what kind of attribute should be there. Sometimes it will not be said, and it will be just building the relation. So it depends on the various levels from junior to senior as the expectation gets changed, and also there will be some variety. So we'll cover more on that. And next, SQL also brings one more thing, that is a various different kinds of SQL queries will be asked, other than the concept of normalization, denormalization, and few other theoretical concepts. SQL query is also another very quite a big aspect which you will be asked to write down the queries there on pen and paper. And then if once we are done with the SQL server there, SQL, and as well as it continues the data modeling, then also there will be some data structure algorithm courses, and say This will cater to various of problem solving questions. It's not too much of details of data structure algorithms, but you should know basic details of data structure, like what is a stack, queue, and in such dimensions. Bit of problem solving. That's where this kind of rounds will focus on. Other than that, there are other tools as well. Like one more can be very related to the SQL and data. SQL is a SQL, NoSQL. There will be multiple questions like, okay, why you choose SQL, why you choose NoSQL data, what kind of NoSQL data you would follow, would you like to use, and what is the benefit does it bring? What would happen if we would have chosen something else? What would the problem we'd have faced? Such kind of questions also can expect from this scenario. Then there is that we goes into proper big data tools on Hadoop and Hive. This is one such things, and then Apache Spark. We have worked on Spark streaming and Kafka. So Kafka, there are a few other tools will be there. Like sometimes you can get asked about Kafka, and then it may cover HBase, then Redshift, or in general AWS. A little few things can be asked, depends on the profile or on the work being done in the company you are applying there. And several other things, like it can be Airflow or Scoop. What does those things? There's a very minute part of things, depends a little bit on very few questions out of the major things will be lying in this first six things, majorly on the, say, if you go for senior and or even mid-level roles, then they'll be majorly focusing on the SQL, and NoSQL, Hadoop, Hive, and Apache Spark, and bit of DSL as well. So these are the kinds of topics it would cover. And on the interview rounds, there will be different. Sometimes there can be two, sometimes there can be three. Majorly, it is 3 to 4 rounds as well. And it also varies from level to level. If we're applying for a entry level, maybe some, and maybe uh, a role for which needs 1 or 2 year experience, that will have a little bit different, and it won't go into very much details of all the things. Like, let's say if you are working, let's say if you take on the SQL, maybe at that point of time, it won't be expected from a person who has 1 or 2 years of experience to know very details of the data modeling, or also uh, it can be majorly under SQL queries and be basic part of it. Whether if you go for a senior level person which is having, let's say, um, 4 to 8 years of experience in big data engineering domain, and you go for such role profiles in the interview, then you will be asked more on the data modeling part, because that's where that gets improved along the time we spend in industry. That is the one skill which gets improved a lot more over the time, and that is going to be definitely asked. And you will be also, sometimes it can be given that, let's say if I ask to you to develop the data model for a company like Book My Show, will not tell anything. What are the basic entities we are going to do? What are the possible attributes of those entities will be there? So these kind of questions will be generally arising in case of senior, as the senior level gets increasing on that front. In entry level or even in mid level also, generally they'll be saying the at least the entities, and then from there you can get some idea on what are attributes to be followed for every such entity, and then find the relation. So this way it will be little vary, because the more time anyone spends in the industry, they also get to know how things are being done in industry, what are the typical contents it has. Like if we go for any movie, or let's say take an example of booking in an e-commerce, then um, with the senior or the experience, people will know generally what kind of columns are there in terms of in the table. Yes, Kalpesh, we can explain that as well. Yes, Joginder is correct. ETL is also very much needed. Pratik, SQL is, I think, still will be helpful, but yes, for ML engineer, there'll be a lot more focus on ML. This will have little lesser, I'd say, but SQL is needed definitely. But the what process which you can skip in if you go for ML round is majorly on much details on the Kafka HBase. If you know majorly what does it do, and maybe a little bit more than what does it do. I don't need to go how internals of this particular tools how they work. Let's say if we take example for Kafka, don't you if you do not know much of what does a partition thing, so what does a rebalancing happens, then also you'll be fine because in machine learning the focus area will be gradual. Like let's say in entry level in like first rounds or second round, maybe you'll get more. You can get these kind of questions. The other round, the third or fourth round, majorly will be on deep towards the ML domain. Some example SQL questions. I'll come to that also, Kalpesh. Which algorithm expected from data engineer? So data engineer, if we say it, the first thing let's say you need to know is various data structures. Let's do one thing. Okay, let me write also the things. Ask SQL questions. This is one. Then there are book my show example. My show here diagram. Anything else? Yeah, ETL things also there. Which algorithms? Okay. Yes, Yogendra, this is on data engineering. All right. Okay, let's check them one by one. I'll go to the algorithm DS first, and then we'll go for the other thing, SQL and book my shell take it together. So if you see for algorithm, before algorithm, first thing is that you should know the basics of the various data structures. So as of now, what all data structures you have heard of? All of you have used list, right? In Python. Then you have used dictionary. Anything else other than these two? Sets, yeah. Sets, tuple, list and array, yeah, goes hand in hand. Oh, that's a very nice. There can be few more if you are interested. You can go and read little bit on stack and queue. I think that yeah, strings is okay. Strings is a very primitive one, so you can say so. Okay, so this if you know the basic in workings of these things, then we will be good enough. So the difference between list and array is that array is a fixed set of things. So when you say you are going to create an array of 10, let's say what happens in an array of 10 is that it will first create a space when there will be 10 entries. So how many are there? 2, 3, 4, 5, 6, 7. So we will need 3 more. So when I say array of 10, that means there are 10 places. Now inside these 10 places, whatever I change, I can go and change. I'll not be able to add, let's say 11th one. Then I have to again create new array and change that. Okay, so, sorry Poonam for the issue. Is it better now? Is it clearly audible now? Okay, nice. Then. So this is a first thing is that the array it takes the fixed space. If you go for array is majorly on fixed space. So when you go for list, that means you can easily go and add another element on the list. You can easily go and add, append easily. So this is dynamic, and this is static. That's a difference on list and dictionary. But if we have to go and find anything, let's say I want to search for 5, what I have to go, I have to start reading from the left, and once I reach 5, I figure out, okay, this value is existing, I can directly go. So we have to traverse all the elements in worst case to get an element. If we go for dictionary, you can find things quickly. So in dictionary, it's more often like this: so 1, 2, and then the value. So if I need to search anything and your major operation revolves around searching an element rather than traversing the list or storing it, in that case, you should go for dictionary. So this makes random search very fast. So if you have any scenario where you need random search, you should go for dictionary. Say it is just you don't need the value, you need basically an unique list, then you can go for set, because set means there is no duplicate. So in such case, you can, and tuple is just let's say you have to put multiple attributes, let's say x and y. If you think of a point of in geometry, you have heard, you have read earlier, every point is something called the coordinate where it have x and y. So if there is another value associated, then you can put this value together at one place, and then you can use it in your program. So those are the cases you need tuple. And strings is, like when there's a character not number, also think strings is goes there. Another interesting I got is a heap, but heap is, I think, it's not necessary, I would say, because there will be very lesser chances you may need to go into the heap aspect of it. So I think you can, I'll go and touch what a heap is in brief manner. And let's go to the stack and queue first. So is it, whatever we discussed so far, data structure, what is the use of it? Is it clear on list, array, dictionary, and set? Okay, nice. Let's go and check for the other things. So when you say queue is nothing but in a, what you see in real life. So let's say you have gone to some ticket counter for any ticket, or it can be movie. And say, think of the era before Book My Show. Let's say for 10 years back, when there's a no Book My Show, you have to go to the cinema hall, stand in a queue, and get a ticket, right? So whoever has gone to the counter first, they will get the ticket first. Whoever has come to the line or queue last, they will get the last ticket. So it is always whoever has come first, they will get it. So it is, that's why, like Ankit pointed out, it's a FIFO. FIFO means first in, first out. So whoever has gone to the counter first, they will get the ticket first. And the reverse of it is stack. So when you say stack, let's say you have a bunch of plates at somewhere, and you have placed one plate among another, then another plate. Now that if you want to remove you have put this plate first, then this one second, then this one third, right? But if you have to remove, if you try to remove the one first, then you'll face problems. It can happen that the other plates, they can fall down, they can break. So the safest way to remove is that whatever have been added last, take that out first. So stack, and times also sometimes you can represent in this manner. We'll say, let's say first it goes 1, then it goes 2, then goes 3. And if you are to or delete anything or take something out, then first you delete or take out 3, then 2, then 1. So this is basically called LIFO, or last in, first out. So in case of LIFO, that means whatever has entered last, that will be out first. In case of FIFO or Q, whatever has entered first, that will enter, and that will exit first. So these are difference between stack and queue. And let me go to the next part then. Okay. I see something strange happening. Just give me a moment, please. Okay, I'll go to the heap and then I'll go for the next part. Okay, so stack and clue is clear. What is a real-time cases when you use LIFO over FIFO? When you need the last thing to come out first, and that's a case. So if you use program anywhere, you will need to push the last thing first. And okay, I'll take an example. Are you aware of some that will get more heavy on this side? Okay, and as I'll go. Are you aware of recursion? Okay, then it's easy to explain on the recursion front. Now let's say what I have to do. I have to do calculate factorial of 5. When it's a factorial of 5, that means 5 into 4 factorial. That means 5 into 4 into again 3 into 2 into 1. So how do we get it? Let's say there's an fact. Let's say the call function name is fact. We call fact 5. It in turns basically it returns 5 into fact of 4. Then it calls from fact 4, it calls 4 into fact of 3. That again then calls 3 into fact of 2, then 2 into fact of 1. So this is how the call goes, right? So in case of this is how the program will write, but what happens behind the scene in memory is that it first, now that first the statement gets executed, it enters 5. Then next one gets executed, it enters 4. It is still waiting for something so that it can multiply. Then it enters 3, then it enters 2, then it enters 1. So now fact 1, 1. So I'll do 1 into 1 is 1. So here it will come 2 into 1. So 2 into 1 is 2. Recursion is used any in very I'd say, let's say in programming world it will be used widely. If you are running something, working on a tree, working on a graph, when you have to call the same thing multiple times, recursion will be used everywhere. So recursion is used in lot more places. You in program in if you say for data engineering, it's not that used, but in normal programming of day-to-day code for software engineer, recursion is a must, and will need to write code using recursion a lot more very often. So like here, let's come back to here. So here we're getting 2 into 1 equals to 2. Now that I have got 2 here, I know what to be multiplied with 3. Now I've got 2 3 into 3 is 6. Now I'll do 4 into 6. Then once I got here, I got 24. I know 5 into 24, and then the answer is 120. So if you see here, though I am calling out 5 here first, I have to wait for other things to get computed. Once it has computed, gone till 1, then I'll start popping up this thing in the from the memory. And finally, whatever appeared last, that's something we are taking it out last and calculating the value. So this used gets used in real world in recursion. Let's say on recursion, one more very popular use case you can see is have you seen your folder structure, right? In your machine, you have a directory. Let's say ABC. Then you can create another one called df. Then inside can you can go and create directory. So every directory will have some properties, like it has a name, then it has a list of further files or directories. So same thing is happening again and again inside that, all those things. So this is a recursion. Whatever you're doing for this directory, whatever properties does it hold, same thing will be having there for each directory inside that. So that's how this is a recursion happens inside a machine. And for if in such cases, stack is something which has to be used with. There is no other way of doing recursion without stack. Okay, so is it stack and queue clear now? Is the concept of stack and queue clear? Okay, nice. I'll go briefly over heap and then we'll go and get from it. So if you say heap, what does it comes to your mind? There is something just dumped in a place. There can be many things. It can be stored, right? So in similar way, it is also there in data structure. So basically what happens, let's say I am storing things there, and there are elements in every level. So generally what happens, there are two kinds of heap happen. A heap is there. One is min heap, another is max heap. So what happens in min heap is that, let's say first, because if it's a heap or something, generally you see the shape is bit of this. Initially whatever the width is, that is the highest in the lowest level. As you go on top and top, initially there is the topmost, so that is lot lesser wide, it's not much of a wider thing. So in every level, let's say first level have one, second level can have two, then three, maybe on more, it keep on getting increasing. In case of normal, any heap you see in normal day-to-day life, it can be an heap of garbage or heap of, let's say, leaves. Specifically in the winter season, you can see many places that there's a heap of leaves dumped in some places, and generally that shape is in bottom, it is wider, and it gets narrower towards the end. So in first level, what in the property of mean heap is that whatever element is in the first level, that is smaller than the elements in its lower level, and again whatever is there, that is smaller than the elements in lower level. And for max heap, this is different. There are further also things there like tree and all, and I think this is majorly in data engineering. So if you have any queries on heap, more on that, I'll discuss towards the end. I'll just put a note if we can discuss later, but it's majorly focused towards the data engineering, so I'll more focus on that part. And if need any question is there, I'll definitely come back on this later. Okay, hold on, just give me a minute. Okay. So on, if you say for algorithm side, you would majorly follow the data structure, and that would have their own algorithm inside. Like if you go for dictionary, what all things should be used. There are many other algorithms, but that is something generally don't get asked in much of in the data engineering things. But if you follow the data structures properly and what case you should use what, that is something you can, that is a, I'd say that is something you will need for 95% or 99% of the cases. So majorly focus on the use case of each data structure you want to use, and there will be quite less chances for you to be using queue or strings, or heap is even very lesser. I don't see any chance of that coming in for a data engineering interview. For programming interview, yes, it can happen. Yes, Pooja, please tell. Okay, no problem. So this is goes on the data structure part. Majorly in normal day-to-day coding, whatever do in data structure, it will be majorly on these things. The list. Give me one moment. Majorly it will be list, dictionary, set, tuple, array, and all. Strings is any needed, but For data structure wise, if you know the use of these five, it should suffice. 99% of the use cases will face in the interview problems. Okay, so I'll go for next. We'll go for the SQL questions. And so for SQL, generally there are two kinds of things happening. Let me go on next for SQL and modeling. So for SQL, first thing what you would like to know or say brush up things. So you may think get in old memories of like what you had in your school days or even college, that this particular topic is important. This will be majorly on that way, because in interviews there are particular set of questions or a few set of areas where majority of the questions asked. And try to call out such areas where there are more questions being asked, what are the concepts which are being checked in lot more thoroughly than other cases. So Scala, no, not needed, Joginder. So it depends on the company you works. So there are certain set of companies who like the people to know the languages as well, and then there are other set of companies where they do not bother about whatever programming language they have worked earlier, because they know people can learn easily. But in case of data engineering, generally major of the companies fall in the second bucket. They do not need much of an language expertise. What they need to know, that if you know the in terms of Spark, be it PySpark or Scala, you know the basic things. Only things you need to search maybe on that is a syntax. So that's it doesn't consider very much a big amount of time. So that is not much of factor so here. Majority of things you focus on the concepts of the tools being used, because see in SQL also there are multiple tools. There are MySQL, then there are PostgreSQL, then SQL Server, and now MariaDB is also there, IBM DB2, Oracle. All such variations are there, but their syntax is not very much different. If you know one thing of this, all the list I mentioned, of such big list, if you know one thing well, that would help you clear all other cases. Even if another tool is being used in the company, the syntax will be very much similar, and you will not face much of a problem while working. But in interview you can mention that this is for you have tested on MySQL or Oracle DB, because sometimes there can be very slight differences across the tools query syntax, but that's very very rare. So just SQL, no SQL, Hive, Pig. No, Hive is needed. Hive has a different set of concepts associated with it. But what I'm talking for SQL is basically, if do not need to go and differentiate much of a MySQL, then Oracle, then SQL Server, then MariaDB, IBM DB2, all such things. There is not much a difference. So if you're getting asked questions, and you can just mention, okay, I am whatever I have telling, this is a syntax I have tested in MySQL. That's it. Because these tools are 99% similar. There can be very very rare chances of few differences. So it don't need to get bothered about those things, because nobody, it's not possible for anyone to learn everything or know something. BigQuery is, you can, it's closer to that, because Hive is also very closer to SQL in terms of syntax, but Hive have different concept because of the underlying architecture is completely different. BigQuery is for Google Bigtable. So for SQL, the first thing as a concept, what you should get uh, clear completely on that is normalization and relationship, the ER diagrams specifically. So in ER diagrams, it will contain the relationship and the cardinality. And you will also maybe asked to do MongoDB is NoSQL. I Yes, if you have worked, then you will get asked. If you have not worked, then they won't ask unless somebody has very specific requirement on that MongoDB part. So generally don't need to you I'd say focus on the concepts or the types of tools rather than the exact tools. That's what I'd recommend, because it's not possible for anyone to learn everything. If you know the concepts of it, you'll be able to figure out how it works, what is the syntax for it, and all those things pretty easily. So other normalization ER diagrams, you have to also need to know about the constraints. When you say constraints, then there are referential constraints. I mean, you can think of it as in foreign key. Then there is primary key, unique constraints, all such things are there. Other than that, you will be generally asked to do indexing part. If you're more of a senior person who is having 4 to 6 years of experience, you may be asked on indexing mode. This is majorly for senior roles. Majorly for beginner roles, not many questions you can will be asked on the indexing part, but for senior roles, indexing part can be asked pretty well. So in indexing, there are a few things like let's say, what is a clustered index, what is non-clustered index, and there are a few scenarios on that. We'll cover them briefly as well. So these are the major topics which you need to cover oh, there is SQL query as well. I forgot that. Then there are SQL queries. In SQL queries, you will find multiple things, like you'll get top X entries, then second highest kind of queries. Other than that, you will get something with where group by, having maybe a little bit on lead and lag, and some count and all those things is pretty. I think it's quite straightforward, so you don't face much issues on that. Chetan, I can share the text except with the upgrades. And that's helpful. I'll share. Definitely not an issue. So on the SQL queries, so in these topics, so whatever we discussed, do you have any query or anything you think that we can clarify now? Then I'll go and cover those things. One thing was discussed on the book my show. I'll come to the in the ER diagram part if needed. Other than that, anything lead and lag function. Okay. Yes, ER diagrams, entry relationship diagrams, index, non-cluster. Okay, I'll okay. Normalization is clear to everyone. Okay, fine. I'll go to each and every then in a brief manner. Okay, so now go for normalization. That means you should not have redundant data. Let's say there are, okay, I'll write it rather than typing it. Okay, let's say you're thinking of a students table, and then you have the student's ID, name. This is student ID, student name, address, then some course, then you can enter marks, then you have an year, not year. I think let's keep these things as only now. So now if we have a table which contains all such things, which contains student's ID, name, address, course, and marks, and it will have entries like this. Let's say one. Okay, I think yeah, that would have been better idea. Just hold on. Marks. So in value column wise, we'll get, let's say here one, then I'll get Rahul, then let's call, let's say the city, let's say at right what electronics, then marks is, let's say 73. Then again again for Rahul has appeared for another exam, and this things are same. Let's say this is called computer science, and here he has got, let's say, 87. Then there is another student called, let's say, Rohit, and then he stays in Bangalore. Then maths, and let's just go to 91. So if you think of this way of data, you see there's a repetition here. I know that if there's a student ID 1, that student ID means that student only always have name as Rahul and address as Mumbai, right? So, but the thing is that if you have a data table like this, if you have designed like this, the problem is data duplicacy. There are too many data will be get duplicated. And if let's say Rahul has taken part in, let's say, 10 courses, then there will be 10 entry for Rahul which have the name and address duplicated. So the better way of doing thing is that keep the data for which the duplication is needed to the minimal. So one, what we'll basically do for that, we'll create few table. One is student, let's call it student, and that will have student ID, then it'll have name, it will have address, and that will have value of 1 Rahul and Mumbai, then 2 Rohit and Bangalore. Then there will be another table which is called, let's say, marks. There what will be there, it will be there on student ID, then the course and the marks. So yes, it will be duplicate for student ID, but all the other things, what is there here, getting here. Sorry, I have to write. I'll not go much. One, computer science, and then here two, maths, and then economics, right? 73, 87, 91. So if you see the same data is being represented, we can figure out the same data from this representation as well, and the earlier representation as well. So let's call it design 1. Then this is a design 2. So what we have done here, we have basically divided the data, say of same table. You can still correlate on those things and remove the duplication, right? So this is called as, this is known as normalization. This process of reducing the duplicate data is called normalization. And the reverse of it is that if I combine these two table and then I'll get back the data in this format, that is called denormalization. Just the reverse of it called denormalization. Is it clear now? Okay. So now we're done with the normalization things. I'll come to the year diagram, and before that, I'll go to the constraints and index in a brief manner. So as the constraints, referential integrity is something. If you see here in this particular case, this student ID is actually reference to this student ID, this table's student ID of the. So it is referencing this particular table's data. And all of you know, but if columns increases, then this normalization will become too complex. Yes, it can become too complex, and generally for that, so what it does is that in now there are two tables, maybe there can be three tables sometimes, or four tables. It depends how it goes. And yes, generally they don't ask too much complex of it, little bit complexity and there will be asked, not, it will not be beyond three, definitely, that's for sure. So you don't to worry much about that. Max there will be 5, 6, 7 tables. Otherwise, if they ask only one table of, let's say, 10 columns and such things, then the majority of the interview time will be going in that only one question, because that, anyways, that whoever, doesn't matter how much proficient he or she is, that question is going to take some time. So Generally don't people go for long questions on this one. Just check whether he is aware of the basic scenarios or not. Okay, so now we'll go for primary key is something which is unique for all rows. Like if you see in this table, student ID is the one which is primary key. This is unique, and every data is dependent on this particular student ID. If I know one student ID, I'll know always the name will be Rahul and address will be Mumbai. For two, it will be Rohit in Bangalore. So in this particular table, there is no primary key. We can add one primary key here as well, but that's a different topic together. So when you say referential integrity, that means I am putting a reference to another table's primary key. The reason is that I have to I have to ensure that whatever records are being stored here, that should be valid entry of a student's. If I put something called 3, there is no entry with student ID 3 here. So this particular data should not appear in the table called marks. So I have to put a constraint or restriction that whatever data is being stored is of a valid value. That's why this is called a referential constraint, because it limit the data has to be valid. It put the restriction. Is it clear now? Okay. And one more thing, if you get asked that whether reference integrity is needed for join or not, it is not. You can join on columns which are not a foreign key and still get a proper answer. It is only to ensure the data is valid. There is no relation of join and this foreign key. So foreign key is not mandatory for join. Okay. There's one more thing you may be asked sometimes in interview. You can answer this easily. Now this is I think done. Constraints index one. What is basically index is needed? Index means what I store a marker. Like if you think about a book marker, somewhere there's a page, you just add a marker there, and if you to know what you have read last, you can just know what page it is there. You can just read, open that page directly. So that makes your query time a lot more faster. If you have to know where you have read earlier, if you have a marker, you can directly open it. And if you do not have a bookmark there, then what will do, you have to start from initially from the beginning until you have to go and read what you have read. Then you can tell for sure that I have read page 73. But while telling that page 73, you have already read page number 1 to 72. The index act as a bookmark there, and it helps us in a getting the data in a very short amount of time. So, okay, let's say I have the data. I do not have the foreign key here. I have a stored data of 3. Can I join the data of these two table? I can join. Only thing I'll not get is I'll not get data for Rohit. I'll get both the entry for Rahul, both in electronics and computer science. So it is not needed. Only thing is that if we have the constraint there and we have a proper data, then I'll get both the data of Rohit and things. But when this is not maintained and I have any irrelevant entry, then it will not have any associated value. So I'll not in join. If you go for full outer join, you'll get a null value there. But join won't fail. If there is no foreign key, join will not fail. Yes, there should be common field, but that doesn't necessarily to be a foreign key. That is the joining condition needed, not the foreign key one. Foreign key is not a mandatory. Yes, cluster, non-cluster, I'll come. So when you say clustered and non-clustered so index concept is fine. Like it's a bookmark, more sort of bookmark, which makes us search a lot more faster. Okay. So the cluster and non-cluster index is something. The data in the table is actually sorted based on the index. For clustered, when you say non-clustered, then it will not be sorted. Now, what difference does it bring for a non-clustered versus clustered is that? So, if for every table can have only one clustered index, because the data can be sorted in only one manner, right? we can't have the same data sorted by student ID and course name. That is not possible, right? So there will be only one cluster index, and if after that also we have to add any more index in the table, then all those things will be rest index on the same table will be non-clustered index. Okay, so tables data is sorted based on clustered index. Is it clear now? Okay, so now I touch upon these things, constraints. I'll go for ER diagram. And for SQL queries, top is a top 10. Second highest is nothing but get top one, and where you match, let's say salary, you are matching. Where salary not equals to top one salary, select. That's the second highest is that's just that way. And where group by having you already know, sum and count also you know. Lead and lag, there's a query and for that. So let's say you have data for sales, year wise sales. So we have data for 2016, then let's say 100, then 2000, let's say for any company stock value, then 2017 it becomes $120. Now you want to know what is the value in earlier year, previous year. So for 2017 it will be 2016's value. So previous year's value is is lag. And when you go for onto next value, like let's say for 2016 row, you want to also keep, so basically you need to copy the same data in of this one in the earlier column. So for we want to know every year how much improvement it has made from the earlier year. So that's why you need to know what was there in previous year. So that for that previous year you need lag, and for the next year it is lead. Next value is lead. This is a new set of statements appear in MySQL version 8. So you can go and take more examples also. Sometimes you may be asked on this part of lead and lag. Okay, so I'll go to the ER diagram quickly then. So it's a ER diagram. How many types of relationships possible in entity relationship diagram? Three. What are those? One. Okay. Hold on. One too many, one to one too many, one to one again, many to many to one. So there are four. They're not there. Yes, four Niti, right? So there are four types of relationship. Now you already know. One more thing, which will gives you a age ahead of other people, is that when you design the diagram, let's of ER diagram, let's say there are two entities. I'll just draw a rough entity of, let's say, can book my show. I'll take something called, let's say I'll take four entities there. One is a movie, which will have things like the movie name, then the genre, then release year, cast, director, and so on. So basically, the all information of a specific movie. That's what you can see for a movie. Then there is another one called, let's say, booking. I'll come to this after. And there's one more. Let's say the other one is hall. So in cinema hall, what you have, that cinema hall name, address, then available screen So screen can be another one there. I think it's not needed here, so I'll just keep it that way. And then you will need for address and that city, then the operating hours. There can be many more things. And when you go for booking, and then there is another things like we discussed called screens. So screens means it will have the everything will have some ID. So it will have hall ID because every screen is for a specific. Raj, yes, I am sharing. Are you able to see the screen? Others are maybe you can try rejoining. Maybe everybody is able to see the screen now. So first screen will have hall ID. Then they can have screen name and let's say the slot time, like is it in 2 to 5 show or 1 to 4 or such kind of things. And that's it. For when you say booking happens for a movie and hall, and there is a customer as well. So customer will be something like this. Other than the I'll just keep the ID. I'll go for name, then address, then contact, and what else things is, let's say, so contact. I'll bring it down again. Email, yeah, break it down. Email, phone. That's all for now. Let's say. Okay. And for booking, what will have? Booking needs to have in use it and high ID. It will needs to have what movie about customer is booking. It will also need customer ID. So for movie, it will movie ID, and then it will also need screen ID, and then it will have, let's say, payment ID, and it will also have timestamp, some timestamp when the booking has happened, also things. So generally this is a pattern being followed here, right? So is this pattern, the attribute definition clear? Okay, now that I have here discussed various entities and the corresponding attributes. So generally what happens in entry level jobs, not entry level, say someone often 1 or 2 years of experience in big data domain. In those cases, maybe they will not be asked to write down the attribute themselves. They will be asked to, they have the entity, you just connect them, or maybe this attribute will be given, or the entities will be got similar, smaller and simple enough to do it. But in case of senior or let's say 4 to 8 years of roles, so maybe more in big data, the people already know what kind of attributes are possible and what all things you can go and add. So in such senior roles, generally they will be ask them to write down the attribute names themselves. Booking is a fact table. Yes, Manamit, actually absolutely right. And the others are dimension table. So this is also one more thing. What is a fact table? What is a dimension table? You may be asked. So if you see the relationship between booking and customer, it is what? It is one to one, right? Booking to customer, it is one to one. So uh, for every customer, there can be a booking or there may not be a booking. Okay. So or it can happen that one particular customer have many booking. So from customer perspective, from customer to booking, it can be zero or many. So the Crowfoot design and the zero. From booking to customer, it is always one and only one, because every booking will belong to only one possible customer. So when you go and define this relationship, you can just do a many, or here instead of just this double bar, you can just go right here one and in, or one and min, or instead of in you can just write this Crowfoot symbol, this. So this is good. Maybe this will sufficient enough also. But instead of one, if you can go for this kind of syntax, which gives more granular idea, that will be a plus point of yours. And specifically, if you are going for senior level, please do follow this way of doing it. That gives you an edge over other candidates. So in entry level also they will be asked to draw a year diagram. So for this case, just for an example, what I have done is basically take wrote down the attributes. In generally that will not be asked because that takes some amount of time. And for initial or junior levels or entry levels, basically they do not ask you to write down the attributes them yourselves. They will just more interested in finding the relation, and then in relation also, if you do instead of one, you can go for one and only one. If you go this thing, this is going to give you an age, because many people who are at the initial level, they will do just this, they'll just say 1 and n. But if you go beyond that and share this is exact value, which is set the expectation, that gives you an impression that you know these things in and out, and you know the data even before the reading the actual inserting the actual data. So try to follow this kind of representation of cardinality while going for ER diagram. Does that answer your question, Lokesh? Okay. So now we are done with ER diagram and other things as well. Let us go back to the next thing. Just give me a moment. Okay. So other things we discussed. So this, okay, this and questions are resolved then. Algo also did explain which part? Okay. So when you say one and only one, that means for every booking, there has to be only one customer. And there will not be any case where for a booking there is no customer. Or let's say here, this, let's focus on this one. That will be more easier now that you're saying about zero to many. Is that there will be customers which do not have any booking. Then there will be customers which have multiple bookings. So based on the customer, it will vary. So that's why it's, though it is one to n, because typically it is one customer can have multiple bookings, that is one to n. But if you go one bit deeper and say that this is zero or many, then you know, it says that you know it quite well, that there can be some customers who will not have any entry associated with them for booking. Those are the customers who just registered in Book My Show. They didn't they haven't or they're pretty new, they didn't get a time to buy a ticket yet so far. So in such cases there will not be any entry, and there maybe there's someone who just check out the movie more of the right, instead of going and seeing it watching in the movie hall. So in such case there will not be any entry. So this gives an edge over others, because it shows that you know things a lot better than just saying one is to n. Is it clear now, sort of? Okay, I'll go to the next part. Just give me a moment. So any I'll go briefly on the big data concept. So in big data concept, majorly major things which you can get asked. Let me write this down there. Yes, this is needed. Is basically all of you know 4 V's principle. Mono with self table, I'll come. Okay, let me go to the self table first. So self table is more of an, I'd say the scenario will arise in case of employee, and there I will have who reports to whom. So where they have a key reference to an column of the same table, that is self reference. There is no not much of the issue, only not much of difference. Only thing is that when you go for join, you will join with the same table. Instead of writing table B, you'll write table A again with table A. While joining, you'll write A comma A. So there is no special difference in terms of self table. Yeah, it sometimes looks odd, but beyond that there is nothing. It just, instead of writing another table name, you write the same table name. Uh, that's the only difference it will have with self table relation. Manumit, does that answer your question? Okay. Let me go back here. Okay, so in big data concept, the majority things are 4 V's principle. That is one of the most popular things being followed. Then there are types of data. You know all types of data, right? Structured, semi-structured, and unstructured. Okay. Then next thing which you can follow is a types of clouds, public, private, hybrid. This you're already out of, right? Then you can follow the these things: infrastructure as a service, platform as a service, software as a service. Are you clear on these three? What is ES? What is PaaS? What is SaaS? Okay, very good. Then other things will go on majorly on the challenges of distributed computing, or you say cloud computing. It generally revolve around these things. Other things goes in the domain of Hadoop and Hive and all those things. Okay, so these are the major topics you can ask, but this is like very say preliminary round questions. Will not be asked too much questions on these things. And now let's go for SQL, NoSQL. I'll touch a bit of the thing HBase as well. So SQL we have already covered. For SQL versus NoSQL, on the major question is being asked is a difference between SQL and NoSQL. This is a very basic. If we talk about cloud, it means big data engineer should have exposure on cloud. Yes, Joginder. Big data and all this. Yes, cloud means AWS, GCP, Azure, right? Yes, because there will be two kind of scenarios. One, such few companies will have their private cloud. In that case, you won't have AWS or something. They use their own data center and all those things. But that company will be very less. Majority of them will use public cloud. So AWS, GCP or Azure knowledge is a plus there. And some companies even expect decent expertise on those tools, those environment ecosystem as well. So on the SQL and NoSQL part, we'll do majorly the difference between SQL and NoSQL. And then another thing which is very nice of sometimes it's good to know, and many cases will get also asked various types of SQL and of NoSQL. Okay, and sorry, my bad, I missed few more things which are bit of, I would say, good to know. And if you are going for senior level specifically, then it is very good to know these things. The two things are horizontal versus vertical scaling and cap theorem. I'll come to this part later. Let me complete this thing. So are you aware what is a horizontal scaling versus what is a vertical scaling? Okay, let me come to that. So when you say horizontal versus vertical scaling, it's basically changing the servers. Let's say there's a small business of, let's say, some coffee shop. In So there is one shop, then it has, let's say, 100 odd users, and generally there's one server of, let's say, 8 GB, and that server is sufficient enough for serving all users operation. Now that particular company or the organization become more popular. Let's say they now open more branches, and now they serve, let's say, around 500 odd customers. So in such more user load, 8 GB is not being enough. So what you do, instead of 8 GB, you go and buy another machine of 16 GB, or maybe in the same machine you add one more RAM chip so that it becomes 16 GB. So what is happening here, same machine is getting better and better. So 16 GB is not enough, then you will upgrade it to 32 GB. If that is not enough, let's say you go to, let's say, 128 GB. So where what you're doing, same machine, and write it this manner, say upscaling same machine, say make it better, and improve the hardware. That is called vertical scaling. And also there is one more scaling where what you do, instead of adding or improving the same machine, you add more machine, add more machine to improve capacity. That is called horizontal scaling. So in horizontal scaling, what happened? Let's say you buy two 8 GB, or it can be, let's say, one 8 GB machine, and then there are another 16 GB machines. So it is growing horizontally, and here as a single machine that is growing vertically. That's why these are two terms being used many times. You'll find these jargons in the normal um, day-to-day job, industry job. So vertical scaling is for upgrading the same machine, and horizontal is for when adding the multiple machines. Okay, now there is one more very crucial thing. So this generally they doesn't get asked for senior level, but for senior level, for junior level or entry level. For senior level, these two terms will be finding quite common. And there's one more thing also very good to know, are there are three things, and write it there: consistency, then there is availability, and then there is partition tolerance. So three things. And if you take the first character of everything, C, A, and P, it's known as cap theorem. So the funda of cap theorem is that you, in a big scale system, you can get I need two of these things. You will not get three things together. You'll get any two. Now, there will be some set of tools which will follow consistency and partition tolerance. There will be some set of tools which will follow availability and partition tolerance. Some will follow consistency and availability, but they will not be goes for partition tolerance. Now, consistency means it is on the data will always give consistent value. You have heard of acid properties in SQL, right? So consistent, the C of the acid is a consistency, right? And availability means you will get always response. No matter whatever is happening, you will be always getting the response. When you say partition tolerance means when there is a network partition happens. Network partition means, let's say there's a cluster of multiple machines, and then you get one group saying one version of the data is correct, another group saying another version of data is correct. So that situation is called partition tolerance. So it happens because sometimes, let's say there is one, we are following master slave architecture or primary secondary architecture in some place, and then the master one goes down, then another node becomes a master. And let's say then again when master goes back up, instead of becoming joining as a slave machine or secondary machine, it says that I am the primary one, and whatever value I have, that is a correct one. So there's a debate between two versions of it. That is known as the partition tolerance. So there are multiple options available. So like if you think of normal SQL, that goes into this particular scenario. Normal SQL server or MySQL, everything goes. They are available and consistent, but in case of large system, they are prone to partition tolerance. If there is, let's say, you may have let's say you are keeping another copy of the data in another data center, and then one goes down, their connection breaks, again it comes back. After some time there's a discrepancy between these two database. So then you do not know, unless you manually know, that which one has the correct or up-to-date data. Especially the correct data is the one where major focus is at. So then there will be a few cases where take example of Cassandra is one, where you can have availability and partition tolerance, but it doesn't guarantee you'll always get the consistent data. Let's say you are updating any let's take a Facebook profile example, and there once you have updated your location, it can take some time to get it reflected everywhere. So it's saying that it will get updated, maybe not right now, it is not updated everywhere, but eventually it will get updated everywhere. So for that, what they say, instead of consistency, they call it eventual consistency. This will be consistent over the time. So in that Cassandra, what follow, they do not focus much on consistency, and in Cassandra we can write in humongous scale of in even million writes per second by adding enough machines. So then there are another set of tools which like similar to, I'd say, go for Mongo, goes in this bucket. Mongo is the one which gives consistence all the time, and therefore also they are in, it can be configured in such a way it is consistent as well as partition tolerance and tolerant, but it is not available. So when you say partition tolerance means when there is no decision can be taken for sure, then it will say I will not be able to serve your response. So that means at for some queries it is not response, it is not always available. You may have also heard about something called HA mode. Have you heard about HA mode? Okay. So sometimes you may come up with this term called HA mode, means high availability. Yes, Aman, right. High availability mode. You will find out these terms or here this term in multiple places. When it's a high availability mode, that means it will always be there to give the response. Now, whether that response is consistent enough or always right or not, that is a different question, but it will always be available to answer. And that covers the basics of CAP theorem on consistency. There are other examples. There are all the data tools, whatever you use, they fall in any of these three bucket, either CA or AP or CP. It depends on that, and you can and you search over it in the internet about it as well. So is the concept of CAP theorem clear now? Yes, Yoginder, please tell. Okay. If captain is clear, then I'll go for the next. So captain is generally not basically asked in the junior or entry level positions. It is when he asked for senior, because that's when it's expected to know more about the cap theorem here, because this would get used while considering for SQL or NoSQL databases. Okay. So I'll go back and this one. So difference between SQL and NoSQL, I think you already know. You have been read it multiple times, so I'll not go much into that. For various types of NoSQL, this is also there. I think you'll get in the course model. Then there are majorly four. Some are key value. This is a more often good to know, but it really helps if we're going for senior level. This is something you should know definitely. Key value based. Then there are columnar. Column based storage, then there is a document based, and then the fourth one is graph based. There are four kinds of NoSQL database available, and age base as well as Redshift. Both falls into this domain of column based, and there is also hyper table. Key value based, here it goes Redis. Document based is Mongo, and graph based is Neo4j. These are major few database names which falls under that bucket, and you'll You have heard of this various types in your, you have read about this thing in the course module, all four types of NoSQL databases. Okay, so this is, as I'd say, this is you should for entry level you can skip, but for senior level this is something you should definitely know, because you may get some questions out of it when you are going for system design. You'll definitely need this thing to design that, so that's something is very good to know on that. And so that's about NoSQL and SQL side of it. Okay, there are few things on streaming and ETL. I'll go over that later. I forgot streaming and also batch processing and ETL. Okay. Okay. So shall we take? I have done PGP in ML and AI. Is this questions will be asked in ML related positions? So in ML, there are not much of. I'd say from this section it will be little lesser. You can like big data concepts and data modeling, something you can look for. But ML, it will be majorly it. So the data engineering doesn't come completely. Like you may be asked one or two rounds, but after the next two or three rounds will be on ML. So in ML, DL, data engineering courses basics, the data structure algorithm, SQL and data modeling, and the big data concept. These are the three things which will be necessary, but not much into Spark or Kafka or Redshift, HBase, like all those things. But okay, so okay, we'll go to the next part. So shall we take about 10 minutes of break and then we'll join for the next part? Okay, nice. Then we'll join again at 7:40 or time. Okay. Okay. Nice. I think, oh, there's only one end session. Fine. No, I was not speaking Hima or Ayushi. I just typed the answer for which Kalpesh asked. So we'll start around 7:40 your time. Okay. No, Ayushi's screen, I didn't share the screen as you look at that. I can do definitely. Not yet, sort of. We're about to start. Is everyone back? Can start then. So Kalpesh, if you're new to Hive and Hadoop, to get to know the basics won't take much time. Hive query is something which you can, I'd say, once you know the basics of Hadoop and Hive, you can spend some time on learning the basics of Hive query. That would help you more on that. So Shivan, for email case scenarios for big data, if you have the basic understanding of how a distributed system works and a bit of and the Hive queries, that would be enough for big data. And for SQL and NoSQL also something which you need to learn. And for if you're going for Python, focus on Panda framework. Panda something which will get used very often. I think you will be need that. So these are major things generally. The Hadoop, Hive queries, SQL, and various kind of SQL queries, and basics of distributed system. I'm not sure, like not too much of Python. If you're able to write normal code in Python, that would be good enough. Not too much of, because it's not a programming profile. It's more of a data engineer. So if you write a basic Python program, that would be good enough. Data visualization is, I'd say, not much of data engineer falls at bucket. Majorly, if you are looking for data analyst role, then data visual is something which will get touched upon. So Virendra, it don't take too much of time if you just read about Hadoop and Hive. I think few weeks will be good enough. Max 2 to 3 weeks. You'll get a good knowledge, or like I think you can just read about it, spend some good amount of time in one weekend and learn the basics of Hadoop and distributed system works. And Hive core is something you can practice, I'd say. Yes, Kalpesh, in that case for data analyst role, I think yeah, data visualization tools will be a good part, and maybe you'll have one round where, other than the queries of SQL or Hive, you may be asked a little bit more on various data visualization tool like Tableau or the Power BI. If you've worked on one, you can focus on that and mention. You can be few more those specific queries of well, like in Power BI, people use M queries, right? So you may be asked something on that. So that depends on very few specific roles. If you are like, if you have worked on Power BI and the company also worked on Power BI, then maybe you'll be asked. But is data visualization something it get focused on more on the business data analyst role? Definitely. Jeff, free course on Hadoop and Hive. I'm not. Yeah, there you'll be fine getting some, definitely some courses on Hive and Hadoop. Basically, if you go for course, then you generally follow Hadoop. I'd say not much on Hive. Hive majorly you can focus on the query. If you're going for ML role, that's what you can follow. For data analyst, coding is not that required, Lokesh. Yeah, you are good at the things you need majorly, so don't worry. You'll be doing great. What MongoDB is, yeah, depends. Like if you are going for big data engineer, MongoDB is not that required. Yes, if you can know the basics, it's good. But generally, it's fine if you're because not every people will who have worked on NoSQL would have worked on MongoDB. Like there'll be some people who has majorly worked on Cassandra maybe, and there'll be some people who has worked on MongoDB, and then they go for an interview where the company majorly works on Cassandra. So these kind of things keep on happening is fine. The thing is that whichever you have worked on, you should have a good understanding of that tool. If you have worked on Mongo, then you should have a good understanding of Mongo. If you have worked on Cassandra, then you should have a good understanding of Cassandra. So it's not that you have to have learned these tool must on that manner. Yes, in the D role, there are, yes, that's correct. There are lesser openings, less than 5 years experience. Yes, but there are, I think, few job descriptions which I've seen from abroad. There are few openings there as well. I've seen few with 1 to 2 years experience requirement. Which skills are required? Data analyst position. For data analyst, Ajay, like I think somebody just mentioned, yeah, Lokesh just like mentioned. Majorly things for data analyst is that you need to have run able to write queries fluently, be it SQL or Hive queries, and then you have to be also able to represent the data properly. Like if you're using Tableau or Power BI, those tools are very widely used across the industry for data visualization, and having some good grasp on any one of them is, I'd say, that is something also required. And you can, for at least you are aiming for data analyst positions, then you should get some good expertise on either of the tools of Tableau or Power BI. That'll be a very good boost. But what about during interview? Because I've seen many ask for coding questions. So yes, so coding questions, Lokesh, whatever being asked, that's I'd say very basic. It majorly for problem solving. So if you have coded on Python, basic things and whatever we discussed on the data structures, like this list, dictionary, sets, tuple. If you just remember these four things, list is for dynamic size collection. Dictionary is for random search being fast. Set is for unique list. Array is for fixed space list. You know the fixed size list of let's size 10 or 20 before and go for array. If you just remember these four things and these five data structure along these four and triple, that will suffice your need for coding. Yes, it is good to do some practice, but not too much. It will not go too much heavy on that coding exercise. It's majorly on the problem solving. That's a major aim of such coding rounds. Yes, DS is needed definitely in different roles, needs different DS skills. For programming, it that's a major thing part of it. For big data, that is not the major thing, but that is also needed. In the end, people will go and write code in let's say Spark, PySpark, or maybe you can learn and write the Spark in Scala. But so all those things need basic things of list, array, dictionary, and all those things. Map, yeah, or somebody will tell dictionary as a map. So these are things, basic things needed for data structures, and not into go for too much things. Like if you go for pretty deep into the programming, or if you look for competitive programming, there will be greedy algorithm, then there will be dynamic programming. All those things are not needed definitely on the data engineering role. What are people who are transition phase and basically doing this course for transition to data analyst job? So in that case, I'd say SQL is something, someone who, SQL is something which should focus really, really hard. You have to be pretty good about it. Other things I think you can catch as a new work on, because both Tableau and Power BI are paid tool. There's a not free tool you can test on your own. So if you have not used in your job, it's hard, like very less chances people will know that about that. So that is fine, but at least you should have good understanding of uh, the SQL queries, and you should know the basic as it what does mean to drill down or see in more details on graph and all those things. Majorly those things you can follow. And SQL is a must, I'd say, for transition or whoever does not worked on the data visualization tools so far. Okay, as in side to practice business problem coding questions. CodeShare one will be too much into programming. Um, what you can, yes, you can do CodeShare, but that's like if you like competitive programming and you are into programming role, then you can go for CodeShare. What you can do sometimes is that you can follow lead code, easy questions. Do not go beyond easy. Even easy also, many questions though they marked as easy, it can be tough. So if you want to go, you can go for lead code, but only easy questions. And if you're not able to figure out much in after let's say half an hour or 1 hour, you feel free to skip it and don't feel any pressure about it. Aptitude test, Nitin, I don't think people ask generally. So that's basic math, so I think we'll be figure able to find it out. So Sakib, you mentioned SQL, and there will be some other things you have worked on other than SQL. WC schools is also good. Yes, for easy, I think yes, someone who WC schools also you can follow. You'll get the understanding. Lead code is the one where you can go for practice. If you want to know, then yes, WC schools you can go on there. And if you already know the bit of least dictionary and you need to be, I'd say, fluent on such things, then you can practice lead code easy problems. But that will still be more of a programming heavy things. So generally, big data doesn't need that much. So Matplotlib and also, so you have some knowledge in visualization thing. Does it is not use Plotly? Yes, so Plotly C1. So that depends also, Virender. It depends on the company to company, because every company follows certain set of tech stack tools, and some company will use Plotly, some company will not use. So generally, we do not need to go by tools, because uh, tools is, I would say, temporary. Concept is which is permanently needed. So focus more on concept. Tools is something okay, you can in use, you will pick up the learning while working on it, but it's good. No need to pay lead code free version. You are going for more programming, so don't go for normal free version and go target only easy. You'll find a lot more examples in the internet, having solutions. If you are get stuck, you can go and search for solutions, you'll get it. So it is more of a very programming heavier, and as you are to do a practice of it, then you can follow lead code's easy versions, but not much. Do not need to go much complex scenarios. For business analysts, I think, yeah, business analyst, data analyst, I think it's more of a same. But yeah, majorly SQL is the one which you need to know majorly. Trini. In terms of technology, mostly TSQL and PLSQL, but for migration of data, learning Python, but not comfortable. Sakib is fine. Yeah, learning Python, uh, I'd say comfortable, get basic understanding of it, and if you're able to write a code in list or let's say dictionary, list and dictionary, then that would be good. I'd say that would cover 70 to 80% of cases. So after that, you can go and also learn some do work on few examples on sets and tuple. That will make it more solid. I'd say full stack data science stays emerging role in the field. So, okay, Mithun, here is a truth is that generally there is no one who knows everything very well. There'll be, of course, a good amount of set of people who knows things in, I'd say, 1,000 feet view, that this tool can be used for this particular use cases, but it's very very hard to know each and everything thoroughly from the depth of it. So that's not possible. In full stack code, basically it happens that okay, you can go and work on it, and while working you can learn for it. Yes, there is also now there are many roles who knows full stack, but still data engineering, code data engineering is something which is still going strong, and it will be in my opinion, it will be strong for good amount of years. Hacker rank also you can go for that, but hacker rank also you go for easy, but hacker rank majorly goes into the competitive programming. Lead code is also that, but lead code is something where is easy to, I said, navigate. You'll just if you go to lead code, search all easy programs, there's a tag available, you can get it everything in an pretty easy to navigate. For HackerRank, there are many things, so it can be hard. So HackerRank have, I think, 30 days of code or something. You can take part. That is a good thing in HackerRank, which goes gradually increasing in difficulty. But if you see anything in facing difficulty or that needs more algorithm, something, you can simply skip it. The BA developer is similar to data engineer. No, business analytics, and Power BI developers go for business analyst, and data engineer is something which you need to go and write code for Hadoop, Spark, and Hive. So there are quite good amount of difference on those roles. There are similarity as well, like SQL, NoSQL, basics of Hadoop, and all those are common. Specifically, SQL, NoSQL part is common, and DS is anyways there. But Hadoop and Spark is the one where the path diverges more. Learning SAS do help. Yes, you can do, but it's not. It's not a must. Searching for senior data engineer to data scientist profile. So if you go for data scientist profile, yes, you need to know the concept very well. That's something and recommend Jeevan, because everywhere, it's not just here, everywhere you know the concepts, you can go and use any tool. It can take some day for you to get comfortable to the new syntax or something, that's it. But it will be definitely after a month or few months or 2 months of joining, you'll be as fluent as in someone who is working on that tool for quite some good amount of time. Yes, Omar, GCP infrastructure, if you go, and it will be good for you to get more exposure, because here in the upgrade course you're using AWS, which is in AWS by far a lot ahead of GCP in terms of market share. But it is very good that you are getting another way of doing it, in that you are getting that exposure. So yes, it will definitely enrich your knowledge and help you on that. So there's an AWS of big data. Basically, what happens is that AWS also have their own version of every tool. Like if you have come upon of AWS RDS, AWS RDS behind the scene, you can give us the option of using MySQL or Oracle or SQL Server. All such options are already available. So they have their own set of wrappers, and they also change it so that it can work in distributed manner. All things are there. So the only thing the AWS term brings here is that knowing or the familiarity of the AWS stack. What, let's say you have used MySQL, what is the corresponding thing is there present in AWS? So that is something you know, and there will be few subtle things definitely will be there always doing, and that in AWS, that's something also going to be help. Other than that, there is not much of difference if somebody is working in AWS or in Azure or private data center. Majority of tools, Hadoop, Hive, Spark, this will be used everywhere. So if I get to work on AWS, and you are you going for data engineer role, someone new? Yeah, data analyst. So in data analyst, then you should go for SQL queries heavily, and then Hive queries. Other than that, you can also, the Apache Hue is not that popular in terms of DA role. Um, Another thing which you can do, it's not in AWS also. There is an AWS version also, that is Tableau, is something which you can look at as well. Big data tools which need to be thorough is that Hadoop and Spark and Hive. These three things have to be completely clear, specifically Hive and Spark. Lakshmi, there are a lot of cloud certification for data engineer. I haven't done much certification. I have learned through my industry experience, and I'm not the good person to comment on anything which is good or something, because I don't have enough knowledge on that. MS offers certificate program in data science. Yes, MS offers multiple certification programs in Azure, and there are few on data science as well, if I'm not wrong. But I don't know very like I cannot tell you rightly the course name. I don't remember that much. I have seen few, but I don't remember the name. So it's not more about the certification. If you do it at any good place and learn thoroughly of the concepts, that would be sufficient. For someone applying for ML engineer and data scientists who are expected to know informatics, informatics, BDL, DDL concepts as well. Yes, DDL is definitely needed, because you will go for SQL queries, and yeah, Informatica, right? Informatica is more of a DA role. It's good to know for ML, but it's more of a DA role, let's say. Yeah, but it's good to know, definitely, Informatica. Okay, so I think we took quite a good amount of question. Okay, there's one more, and then we have to get back on the other parts. If we get to work in data scientists in AWS with things self focus on, so someone who, again, for data scientists also, you Hive, Spark, these two you have to be completely clear on DS roles, and other than that, depends on the company. You can learn the tools there which are getting used there. So for DA and DE role, so for DA is basically analysis, right? So in that case, what in the focus, let's say the beginning, it goes on the SQL, and the queries, a bit of NoSQL also, and then Hive also. So more of writing the queries, where if you go for DE role, it goes on writing a bit of code as well, so that you can do a lot more custom things there. Like, let's say if any company has a different set of rule, business logic has to be get applied, which cannot be done just by writing query of it. In those cases, they have to write some code logic for it. So that goes into the domain of data engineer, and bit of data scientist is little different. Data scientist also goes to the that, and on bit of ML as well. And for DA, it's more often the basics of SQL and how to be able to query and get the data. So data Uh, Engineer is someone who takes care of the infrastructure and how you can get the data, how you can combine, get the data from places, and how you combine so that it can be further queried upon. That is what the job of major role a data engineer performs. And for data analysts, they know that there is a data, how we can do run some queries and get some pattern out of it which is not there directly visible. I can figure out the mean few insights of the data that goes in the DA role. In Hive, we have multiple concepts, specifically beeline commands, insert, override are supposed to be well versed. Arga, yes, it's definitely if you're going for DS or even DA, Hive is something is very crucial. You can go for definitely insert override. Insert override is not that very used, but at least for normal other queries like select, where, group by, all those things, and the UDF is something also good, and also a map join. Insert override it's not that much popular in Hive. The majorly aggregation queries is the one popular, and you should focus majorly on the aggregation queries. Okay, so is a Tableau or Power BI person without spending much? Kalpesh, I think as much as I know, both Power BI and Tableau are not cheap. Both of them are. Yeah, I think there can be some trial version. You can try it for a month or so for Power BI, but I'm not sure. You can check for trial versions. But for productions, both are quite costly. Okay, so let's get back to the next part. So then we are discussing about SQL, NoSQL, and I'll go for Hadoop and Hive, Spark, and okay, I'll go from this manner. I'll take this thing last, and we'll go a bit deeper on that. So Ankit, yeah, oh, that's a great Ankit. I think yeah, 6 days is good enough to get some hands on that. But so I think yeah, that's what you can start if you have more interest on that. Okay, so for Kafka, we'll go tools one by one, briefly on what it helps. HBase is a NoSQL data store, which we discussed, and Redshift is very similar to Hive, but Redshift differs in a manner. So, Raven, if you have 12, 15 years experience majorly in different, is any of them on programming the domains you're saying, Raven? I'm sharing the screen, someone new. So Ravin, if you're going for, if you have experience in programming, then yeah, then I would suggest going for data engineer or data scientist role. Okay, let's go back here. So okay, so we'll go by one, and let's go by from the this side. HBS we discussed. Scoop, what is the screen visible now? Okay, let me reshare. Is it visible now? Okay, good. So come from right. HBase we already discussed. Let's discuss other tools in a brief. Scoop we already know, right? Apache Scoop. What does Apache Scoop use for? Pratima, I think if it's in education on the professor side and professor role, that's a very good. I think you can go for it. I would recommend a data engineering or data scientist role for you. Yes. So Vijay, if you right, structured data transfer. So Scoop is used when you need to move data from, let's say, MySQL to Hive or Hive to MySQL. Instead of Hive, it can be normal HDFS file as well. Or instead of MySQL, it can be Oracle, it can be SQL Server. All kinds of data storage are there. Even Postgre and IDBM DB2 as well. That is where Scoop can be needed. Let's say you have an data about for products in a MySQL table, and you want that data to be synced to Hive so that you can use that table for further join queries in the Hive. Those are the cases which you should use Apache Scoop. Airflow is the one which is used for scheduling, right? Yeah, you have basic idea of what an app Airflow is. Airflow, what that this tool does. Okay, so basically, what happens sometimes when you have, let's say, multiple jobs to run. Let's say there is job one, and based on that job one's output, then you should go and run job two. So in that case, what happens basically is that it has, and also in that the job one, let's say it has to run every day at 1 p.m. And once this just job is over, let's say generally it goes over by around 2 hours, so it will get 3 p.m. job is on, which will get triggered. So when you have a such relation, when you have one particular job to run before another job, and that job is running periodically, in such cases you can use one tool called Apache Airflow, which basically creates a flow diagram of various um, job. Along, and job is basically nothing but a script here, and you have a dependency or sequence which needs to maintain that one job should run for after another, and everything has to run in periodical manner. In such cases you can use Apache Airflow for scheduling, and you can go just take a brief note of it, and that's it's not needed that much unless you see, if you see uh, so one good thing you can do is basically for any role and role, if you see the job description, if you see some tool is being used, it is good to know, go and read about it. You doesn't need to say that okay, I know this tools completely, don't do not use fake or something. Yes, Ravin, it is very much similar to crontab and scheduling, but the thing is that crontab doesn't have the dependency thing. Apache Airflow takes care of dependency as well. It is also in scheduling manner, it's very similar to crontab, Ravin. So in any job description, if you read the tools, then also one the good thing is that you'll get an idea what kind of work you are expecting there, and what kind of tool that things use that will give an idea of or give a good grasp, or so they can also connect to various dots there in the interview. That will help definitely. AWS is nothing, and for Redshift, it is very similar to Hive. The only difference between Redshift and Hive is that Hive doesn't store anything. It just read the data line by line from HDFS. But Redshift, they have their certain different way of storing the data. Redshift and HBase store data in columnar manner. So when you say columnar manner, let's take an example of the next one. So if we take this example, student name and address, generally what happens? The data is being stored in this manner, right? Row after row. First row, sorry, change the color. So there is first row which contains student ID, name and address. Then let's say there is a new line, and the next line stores student ID, name and address, this manner. And if I want to store in CSV something, what I'll do, I can put a comma in between. So this is a general typical way the data is being stored. Ajay, I'll discuss more on that. I'll in the towards the end I'll try to share a few things. Varun, I'll definitely share the OneNote notes, definitely. Either this file or I'll do an gist of it and share the document. Definitely I'll do that, Varun. So in normal database, what you see, we have seen for MySQL, we have seen for SQL Server, or all such cases, they store data row by row. So this is the example. They store first this particular row, then this row, this row. So this is actually line 1, this is the line 2, then this is line 3. That's what it stores. But let's say I have to do an query, I have to go read all these things first, and all the lines, and let's say I'm looking for some record of having of 2. I am searching with one, two. I'll have to go and read for all the lines, and then I'll figure out that two is the line number three contains a record about student ID two. I'll come to that, Pilori. Just let me go over it first. I'll come to that. So in the student, so this is how generally stores. What it happens is that in case of Redshift or HBase, they store it in column by column. So they store it this way. They store first student ID, and they store in one. If I just consider this table, it will store one, then one, then two, then they will store data on course. They will refer electronics, then computer science, and then maths, and then marks, and they will have again three entries. So they store all data of a column together. What benefit does it give? If I have to query on anything, I have to read less amount of data. If I, let's say, I'll need to do a query on student ID, instead of reading every line by line this much, I can get it by reading less number of content. Earlier I have to go one electronics 73, I have read this, all this complete data has come into memory, then again I go for one computer science and marks, then I go for two. So it has lot more to read. If we go for columnar or columnar, or say column based storage, in that cases it is stored in column by column manner, so searching is also a lot more faster. So this is getting followed in HBase and Redshift. So that is something will be definitely asked if there is a question related to HBase or Redshift. You can definitely expect this kind of questions. So is this part clear on the column based storage? Okay. So now I'll go back to the next part of it. Then there is one more thing on Kafka. Kafka is something, let's say there is in streaming anywhere. If we go for streaming, so there are two things. One thing is streaming, another is batch. So batch is something, there is a periodic job and it get a batch of rows. Let's say it gets all rows of students table, or it reads 100 rows at a time of student level, then they process, and then they go and read the next 100 level. That's how it a batch thing works. Then there is something called also streaming pipelines. So is also getting a lot more popular now. Streaming is real time. So the real time, if there one message comes, it will process then and there. It will not wait for to have 100 records, because in case of batch, what happened, it is waiting, it will take 100 records one, and it will get, it's a scheduled job, it will run, let's say, once in 1 hour, once in 2 hour. But streaming is real time. Once any message comes, it will get processed at that point of time. It's real time. Now on streaming also there are two different ways. There is one thing called Apache Flink, which is true real time. Then there is Apache Spark. They do something called micro batch. So I'll briefly touch upon these things. On say true real time, that means it process them one by one. Once it comes, it will go and process. And Apache Spark, they brought a different concept. So what they have done, Apache Spark was traditionally a batch processing based system. So there is one job which runs once in every hour, and then they get the data of whatever has been come for that last hour and process it. And this adds a delay. So one particular event, even though it has let's say let's say I have a job that runs once in every hour. So first it runs 7, then it runs at 8, then it runs at 9. So let's say there is one event which comes at 7:05. So it has to wait 55 minutes. It has to wait for the job's next run, which is at 8 o'clock, and then only it can get processed. So the waiting time is the one which is a major concern for batch processing system. And some many places this is absolutely fine. They can go for batch processing. And also there are multiple problems also streaming brings to handle. And for batch, those are not there, so it's easy to handle those things. That's fine. So but Apache Flink is true real time. It processes events one by one as and when they come. It doesn't wait for the 55 minutes like here. If it comes at 7:05, 7:05, then it will be processed 7:05. If it comes at 7:01, it will get processed 7:01. It will not wait. But Apache Spark, what they have done, they have reduced the size, reduced this interval from 1 hour to a very small amount. It can be 1 second, let's say. So when you say 1 second, there is, or let's say even 100 milliseconds. So that means it is not real time, but the delay is very minimal. So this is near real time processing happens Apache Spark. This is called micro batching, and this is also goes under kind of streaming. It's nearly getting processed instantaneously, so that's fine. Not much of difference there for Apache Flink and Spark. Yes, there is definitely slight latency is being there for Apache Spark, Flink, Apache Spark, because it is micro batching, but that's pretty negligible. And in very applications, it doesn't matter to whether there is a delay of 10 milliseconds or 50 milliseconds. It's absolutely fine. And if there are some which are very time critical, in those cases, yes, true real time is can be used, and Apache Flink can be there. The problem with Apache Flink is that Apache Flink is a little bit new. If you are going for Python, there is not very good support of Apache Flink. If you are going for Java and Scala, Flink has very good support on. Flink has been written in Java, so you can use it as it is. For Spark is quite old in the market, and it has a lot more support for all kind of actions in both Scala, Python, Java, R. There are multiple other languages it has support. So Spark is this is still more popular, and it is being more widely used in the industry on there. Now that we know what a batch and streaming is, for streaming, what happens? There are two components. Let's say component A is component connected to component B. So the component A has to be connected with component B to some way, so that whatever the component A produces, it will be read by component B. But as this is of that it has to be done instantaneously, till the time it will get stored somewhere. So data, what does A generally writes the data to this queue, and B consume the data from it. So Kafka is a message queue. And for any streaming applications, you'll find Kafka is present in nearly all of such streaming applications for connecting to different components. So it can be very well, let's say if we go for let's say fraud detection. So let's say after ATM transaction happens in a bank, then there is a fraud detection unit, so which runs in the read the event, all the event from ATM transactions, and then process and they store the data somewhere. So it can happen, so the all the event, whatever transaction is happened in the ATM, it gets sent to the another component which will be reading it for the fraud detection. It is not that A is waiting for B to give a reply. It is A has informed B that there is something happened, you now go and read about it and do your necessary operations. So in these cases, there's a queue being used, and for that Kafka is very popularly used tool. So if you have already read about Kafka, you can go and read about be prepared well on that, because Kafka is also sometimes you'll get asked in the interview. And if you have not worked, or if you have not read on the Kafka, it's absolutely fine. Especially if you're going for an DA role, you will not need much of knowledge of Kafka. But for DE, it's good to know. If you have read about it, please prepare on it pretty well. Kafka is a very good tool, and it's widely used. So if you know on those things, you can revise very well. That's going to be used a lot more. Okay, then there is something called ETL. ETL is, the full form is extract, transform, and load. You say extract, transform, load. you have to extract the data from some place, then transform into another, and then you have to load into another place. So let's say you have, I'll take the example of this thing, the earlier one. So you had data in this manner in the student, and it's called student marks. That's better naming would be. And you have read every row from them one by one, and then you split the data. You have understood the meaning because you are reading it from the schema, and then you transform into a different format. So here you transform to two different way of writing, two different data sync, it would be called, to place to write. And once you write, that writing is part is loading, because you're loading the data from one system to another. In between there's a transform, there's some business logic is getting applied, which ETL is used in OLAP. Yes, Samanu, it is used in OLAP. And even for machine learning, ETL is also used. And so that's where the relation or the need for Hive comes. For machine learning, you'll write, you'll prepare data, clean the data, all those things. Let's say in machine learning, there are few vectors you have already used, and you want to add few more vectors by calculating some data. Maybe just by the data combining few more attributes, or maybe you are reading from some external data and combining that data with the existing, so to add few more attributes to it. So in those cases also, this addition of new attributes or creating new attributes is called transformation. Reading the data from the source and get a meaning out of it, that what this particular column means or what this particular key value means, is the extract. And load is that writing the data to the another system. Okay. ETL versus ELT, Niti. I'll come to that next. That's a nice, very good question, Niti. And OLTP to ETL, then OLAP. Yes. So yeah, that's also one sequence you can say, sort of. So OLTP is something which is happening first. Generally, that's where the event gets generated, and then somebody, people who are using it so that you can use it for querying later, that is the OLAP. There they can they need to store the data, transform it from one way of storing the data to another way of storing another schema, and that's what ETL is. So sort of that's a very nice proper example of it. Okay. And let me go back here. Okay. So Kafka is there, ELT. Yeah, I'll come to the ETL and ELT. So just give me a moment. So when you say ELT, first thing is that you extract, definitely, then load the data, then you can transform it for in the place where you've already loaded, that you can go and change the data there, or you can transform it so that you can pass it to the different pipeline. Let's say for credit card fraud detection scenario, you have figured out that some informations you have written to, let's say, okay, I'll take a real example so that make it clear that. So first it contains the, let's say, card number, amount, customer ID. Then what it does, then there is another queue. It, that's what this message was being sent. Then there is another component which is reading it, and they will also read some externals from the some external source. It will get, let's say, it will store the past history. The another thing it needs to know is the, sorry, past history. So once it get the event, it will also put an entry there in the past history. So this is the load to the new system. The data gets added there, and also it can further filter out few things. It can transform the data to filter out. Okay, this particular event is fraudulent transaction, yes or no. So it can branch out to two different queues, or it can just give only the fraudulent ones to this queue and just discard the other one. So after this, in this case, what happens, so after extracting the data, loading into another system, and then finally it is storing the data for transformation to the next system. So these kind of systems are ELT, extract, load, and transform, but generally it is lot lesser than ETL. ETL is which is being there for quite some time, and major scenarios falls under this case, but there are few multiple scenarios coming in this domain, and in such cases ELT is also being used. So it depends on the requirement, on the way you are designing. And this is the one designing is this designing is aspect is the one which is basically for quite senior data engineer role, maybe close to 8 years, 6 to 8 years kind of scenario roles, where you'll be asked to design such data pipeline. Okay, so here only. Now I'll go briefly on Hadoop and Hive. So on Hadoop, you already know about, sorry, regarding Hadoop, let's go on the topics briefly. So you know about what a name node is, what a data node is, then what is a standby name node, what is secondary name node. These are things you know, right? Have you read about these things in Hadoop? In Hadoop, you know that have you, if you have read Hadoop, then you should definitely know what is name node or something. Okay, I'll go briefly because I have to touch upon the other things. Just let me. Okay, so in Hadoop architecture, this is generally follows. It goes to connect to an HDFS client first, and then there's a master node which knows everything. At least it acts in such a manner. Every thing what happens, that it first gets asked to name node, and name node needs to know few informations that uh, what or what is the IP of the machine where this particular data is being stored. In such cases, those metadata is getting stored in secondary name node, and name node reads the information for secondary name node to answer the questions to the HDFS client. So name node is the one which manages these things, and data node is the one where the data is being stored actually. And then there is also a question arises that when the name node is goes down, then because there is only a single name node, then somebody has to take care or take that place of name node so that it can run properly. So for that, Hadoop later introduced something called standby name node. Then once the name node goes down, then standby name node is the one which takes its place. There's another box of it box, and that was introduced later at Hadoop 2 along with Earn there. And they also need to know the information needed. They can go and read from secondary name node. There are actually generally 3 to 5 secondary name nodes, so there are lesser chance of all of the name nodes going down there. So that's, I think, briefly I can touch upon because there are still many things to go. So you can read about these things, but if something is needed on to know for Hadoop. Other than that, you need to also follow more on read path and write path. This is, I'd say, good to know. But what is a name node and this thing, something you should must know because it's needed very much. Along with that, needed is that Earn, how Earn works. And other than that, you can do briefly know about MapReduce programming. what are the phases of MapReduce program? The map, or say mapper, then reducer, then combiner, and then partitioner. So you know, do you know all these things? Barun, it's absolutely fine. And if you're new to Hadoop, you can go to the course on that and read about these things. Majorly, these are things you can touch upon, and that should go. That should do the job. So for MR programs, please focus on what a mapper is, what a reducer is, or what a combiner, what a partitioner is. So these are the major things people get asked on Hadoop, and that there are not too many things. And there are very less chance of we will be asked to write an MapReduce program. But what is the role of these things, the mapper and reducer, combiner, or partitioner? That is something you should definitely know. But generally, people will not doesn't ask what is asked anyone to write a MapReduce program, because that something doesn't get used very often. Spark is the one which will come just after these, which are getting used most of the times. So Hadoop, just follow these things. That would be good enough. Okay, let me go to the Hive part then. In case of Hive, um, one thing is that Hive does schema on read. That means Hive read a difference between standby name node and secondary name node. Okay. So Nidhi, standby is if name node goes down, then it will take its place. Secondary name node is the one which is a bookkeeper. They write what IP is having the data of what kind of any file. Let's say when you go and write, let's say go and write /user /root /temps, let's say then file 1, then this actually gets translated to some IP or a bunch of IPs, let's say. So this particular record is being stored in the as a metadata in the secondary name node. Standby is the one, as the name suggests, standby. If others goes and the name node goes down, then it will take its place. Yes, someone is takes a snapshot of all that information being passed there. Okay. So for Hive, the one thing first thing to remember that it applies schema on read. While reading the data from HDFS, it applies a schema. That is something you need to be aware. Other than that, there are very different kinds of queries. You can do group by, having where also things are definitely there. Some things, all those things wouldn't get follow. Few more things which you need to follow. This is also there in present in MySQL. I'll go partitioning and bucketing. Specifically partitioning, which is getting asked more. Bucketing will be asked definitely, but little less as compared to partitioning. Partitioning is basically in the direct. Let's say you have a table which have multiple columns. Let's say column can be ID, then age, then let's say address, then name, and so on. So what you want to do is basically, because the data is huge, so let's say the data contains every people of India who have got vaccinated for COVID right now. So the data is going to be millions, and it's so huge on that. You don't want to store everything in a single folder, single file, so that the time will be huge. What do you need to do? You know that age is something there is in 10 to 100, and you say that what will do, I'll store, divide it based on the age. For every age, there will be a separate folder or directory, in a better word, I'd say. So in such cases, what you can do, you can create a partition based on age. So what will happen, for separate directory for every age. So in that case, there are also two things. There are static or dynamic partitioning. So in partitioning, I'll go and expand this more. Static and dynamic. Static is that you yourself mention which folder does the data get stored. Dynamic is something you mention the data. This data you have to insert, and Hive insert it at any place and the corresponding places based on the value of that column. And then there's also one more query you'll get asked, that how to change the partition criteria. So sometimes what happens that you want to, now earlier I thought that the age is fine, then maybe other than age, then one more things comes later, let's say like city, then you want to do age, a combination of age and city. In that case what will happen, you cannot modify that earlier table, you have to create a new table, then insert all data of earlier table to the new table. So when you change it, basically create a table and copy all data from the earlier table. That's a way you should do for handle the changing of partition criteria. And now if there's a part you want to further break down into multiple files, in that case we can follow bucketing. You, inside age you can give the number of buckets. Typically you try to create, let's say 1000 to 10,000 entries per bucket. You can go for million as well, but not more than, definitely not more than million. I should try for not per bucket. This is something you can see. So bucket means for every bucket one file will be created, and for every partition one directory will be created. So these are two things. And one more thing, if you specifically, if you are going for DA or anything, anyone with more focus on the queries, you can read about is Hive map join. So Hive map join is one way of join where you read complete information of one table. Really it has to be small enough, and then read the data and keep the data in memory. So there are two different machine to join. You have one machine's complete, one table's complete data in your machine's RAM. So Hive mapgen is a lot more faster, but the table size has to be small enough. Yes, I mean reducer is not completely reduced, but yeah, it does very lesser jobs, because it is not necessary that you can just, there will be two tables join. There can be multiple tables, like maybe 3 or 4 tables join, and you can use map join on one table because one table is small enough. Yes, reducer has lesser work to do now. Definitely someone new. Okay, shall we move to the Spark part then? Okay, I'll go. Just give me a moment. So for Apache Spark, the first thing is that to read about for Spark RDD, that you can go briefly touch upon an RDB, the data frame, dataset API, and briefly on Spark SQL as well, but not that needed if you're going for data engineering. Yeah, it's good to know Spark SQL, but just see the example of it. That would be good enough. The majority of things go for Spark streaming, and there we'll need for transformation. We'll go each of the multiple transformations one by one now. So what does transformation means? So for any architecture of a typical streaming application is like this. It will be, there is a source, then next there is where it applies a business logic, which is called as transformation. Then it finally writes the data into somewhere, which is called as sink. Now there's, it can be definitely some queue over here, or it can directly write to the sink as well, any sink. Now source can be anything. It can be your MySQL, it can be your Kafka. Sorry, my bad, here it shouldn't be queue, my bad. So in source, it can be Kafka, it can be MySQL, it can be HDFS, and there are many other things possible for that. The same things is also possible to write the data. So it's basically where we are reading the data from, and this is where we are writing the data to. The main logic, whatever change happens, what the business logic, everything, every magic happens in this particular part, and that's a data transformation. So for transformation is basically the major use case for Spark streaming. So remember, discuss the Spark streaming uses micro batch few minutes back. Okay, so that is something also will be can be asked in the interviews about how Spark streaming works internally, and you should be able to answer that properly, because that's on the base of the Spark streaming. And other than that, in transformation, there are multiple transformations available. On one of transformations, you can just give me a moment. On transformations, there are something called map. Map is what? Convert data type of A to data type of B. That's the rule of a map. One entity of type A to one entity of type B. That's what the map function does. You have used map there in Spark streaming. Okay. Then there are few more as well. Next is flat map. Okay. So Vipul, if you have not read about Spark streaming, just done example, please go and take check. I'd say recommend going for the Spark streaming documentation, their website itself. I'll share the link towards the end of the session. You can get idea of various transformations available there. Transformation is what you have got one kind of data, you apply the business logic so that it can change. And you let's say if you take the example of fraud detection, so it has got the ATM transaction data, then other than that data, it also go and read about its past history, maybe some more data of geography, location, weather or something, and finally figure out whether this data is a fraudulent transaction or not. So it enrich the data it has got and transform into another data, another format. Because if I'm passing on the same data, then it just filtering, that is also having a use case. But there are many cases also need to go and add few new things so that that can be used later. So in such cases where I have to add new things, or I need to reduce the number of attribute whatever need, in such cases we should be going with the map. Next there is flat map. It's necessarily the same of map, but it is just convert one entity of type A to zero or more entities. Let me sorry, let me just clean this up. Okay, so I'll get back to here. So that's a use of flat map. Okay, then the third most used thing is a filter. Filter, you know that it will take or skip few of the entries. Then there is another one which is also being very used, is union. So union means you are getting two sources and you want to combine them into single source. combine into single source. That's the job of union. Is it understood so far? Is it clear so far? Okay. Then there are few more. I'll not. There are multiple. I'll not go of many, but the major ones which are very much asked in the industry. Intersection is get the common of two sources. Then there is group by key. Group by key is similar to SQL group by. So what does group by do? It basically keeps all the, what does it keep? What does group by do? Let's say when you say group by id, it will keep all the id of one value, id of value 1, all the rows having id value 1, one after another, then id value 2, and so on so forth. Generally it doesn't go and if you want to do now after group by, we generally do basically is a aggregation on that. So for that there are two more things. It is reduce by key, and then there is another called aggregate by key. You can go and read about it on the documentation. And there's one more, I'll not go more than that, that is sort by key. Sort by is order by, you are sorting by something. So these are the major transformation functions. I think it's better if you practice on this one, because this can give very well asked in the interview, what kind of transformation is used for what cases. You'll be given scenario where you have to add few attributes. In such cases, what kind of transformation function would you use? Can anyone answer that? If I have to add few attributes to a specific entity, then for transformation functions which we discussed here in Spark Streaming, what would be the transformation function which you will use here? Out of the ones we discussed just now, you can see this list and tell. No, you have to add few attributes, not aggregate. Aggregate is different, right? Aggregate, you're combining multiple things into one. Yes, map. Right, Lakshmi. Map is one, convert one entity of type A to one entity of type B. So adding means it's changing the schema. Union means you are having two different data source. Let's say there are some sales data from one source and some sales data from some sales entry itself and in another event basically. So this is two different set of events, not same set of events. So in map what happens, same set of events is there, it just gets more enriched, or let's say it doesn't need to go and read about all the data, all the attributes. We can reduce attributes as well. So in this case, when you are adding few more attributes, map is the one. And let's say you want to convert one to multiple. In such cases, and along with this adding new attributes, you can go on flat map. So flat map is used where, let's say I had in a source, I had one list. Let's say you think of hobbies. All of us have multiple hobbies, right? And now you want to get the hobbies for a person, and every hobby you want to process separately. What will do, there will be one to multiple hobbies. So that's where in such cases you will be using flat map. So one person can have multiple hobbies. That's why it is exploding more, or let's say the number of entries will get increased here. In such cases, let's say in hobbies I don't need much other things, I just need the list of hobbies. So what will do, I'll do a flat map of the users data, and I'll read only the column hobbies. I'll discard all other columns, and hobbies will send for the next set of processing. Okay, is this clear so far? Okay, now that we're done with the transformation, then next thing is the writing the data. So I think schema I'm not going much. Schema is also something which you need to know. There you can just it's all of follow same thing. Struct type is a major thing which you will be following there, and that is straightforward. So I'm not going much into that. But in Spark Streaming, if you specifically are asked to write code or something on or debugging something, struct types reading the schema is very needed, and you can read. You can also get something a few more on what is a Spark context, what is an streaming in streaming context. All such things also can be asked as a theoretical question, but majority focus will be the on the transformation and also the writing to sync. When you say writing to sync, there are multiple ways of writing the sync, right? There is something called save as text, then save as object. Save as object is for blob store. One store is a little different, it's not just normal file. And save as text also we can give the encoding format and multiple things. Then there is something called, which is these two are the major ones. Specifically save as text is the most popular one is there. And also one more thing is there, you have to see is that may have seen for each RDD. Have you used for each RDD? Ankit, I'll definitely share this notebook. Have you used for each RDD? Okay, so this is a generic one because when you, in case you do not know what to write and there is not something which doesn't get matched, so it is lesser scenarios there, and it is also for anywhere you can write. It can be to another stream, it can be anything in such cases, and can use it for each RDD. This is the I would say these are three major one. Most used one will be the save as text file. This is the most used one you'll be getting. And here also think about the encoding format. So when you write the data to Hive or anywhere, you can also mention as normal say text file or the JSON. All those things variations are there, you can read about it. And also one more thing is very important, so I forgot it earlier, that is watermarking. Are we know do we know what is an watermarking is? Do you remember? Okay. So, have you been ever late to the class in college or school? Mrs. Class starts at 10 a.m. and you have reached at 10:05. No one? All of you are on time, always on the classes. Sometimes, right? So, watermarking is like that. So, some teachers, what used to do, if the class starts at 10 a.m., specifically this happens in college, most of the places, teacher will allow that, okay, if a students come at 10:05, it's fine. But if the students comes after 10:15, 15 minutes after the class has started, then the teacher, then the student cannot attend the class. So for some teacher, it will be maybe 5 minutes, some teacher can be 10 minutes. It depends. So watermarking is also the same thing. It says, okay, I'll read in, so let's say current time is 10. I will wait for any event which is there having a timestamp of 10 o'clock. This is a, let's say, event time. Event time means when the event has occurred. So this is one event which is getting say E1. But even though the event has the message has been generated at 10 a.m., it has reached, let's say, 10:05 a.m. It took some time because of some delay, XYZ reason, it got delayed. So when you say watermarking, and I say that I'll allow 5 minute lateness, that means if one event which happened at 10 a.m. and it comes for at 10:05 a.m., I'll still process that event. But instead of 10:05, if that appears at 10:15, I will not process. So if at 10 10 a.m. generated event appears at 10:05. Okay, I'll do after this. Then this is accepted. And if it appears at 10:06, it is rejected. So watermarking is the one by which we can say that I'll be waiting for one more minute of window, or maybe 5 minutes of window. I'll wait and consider those messages for processing if I give that watermarking. So watermarking is also very widely used in the industry because there can be delay in many reasons. So some few minutes of delay latency it allows, but it doesn't wait for everything. Otherwise, it becomes a batch processing if it has to wait for that long. So watermarking is another very important concept which is being also used. I think, yeah, that covers the majority of the requirement for Spark and all those things. And let me also launch the poll at the time. Okay. And I'll now please ask any questions, generic questions if you have. So these are the major things and topics I would request to cover for Apache Spark interview, specifically transformations, output, and bit of this thing. What is the context? What is streaming context? All those things. Any questions on anything so far? In industry, AWS is maximum market share, and that is a major reason this course follows AWS. So for email, like Varun mentioned earlier, ideally you should go for SQL, learn SQL very good manner, and for in distributed, you can focus for Hive. Other things are like basic knowledge would be suffice. Apache Spark is good to have for. Oh, DA is not that much. Apache Spark knowledge that not that much needed. You can have, it's good, but not that much. What are common questions in Kafka and Spark streaming for senior D? Spark streaming, I think these are things you need. And you may be asked of what an executor is. Executor is how much resource you are being getting used for the Spark. That is one. Executor. That is one more. And for Kafka, if you go, then you should definitely go for partitioning, rebalancing, concept of consumer groups, topics. Majorly partitioning, rebalancing consumer groups. These are the major things, and also how to scale. This is for Kafka. This is one more very important questions get asked. So when you say how to scale, what is basically only thing you can remember is that number of partition should be number of consumers. That's the only major rule of scaling in Kafka. Scala Zookeeper is not needed that much, Niti. You can skip. Scala definitely you can skip, and Zookeeper is like very senior role, and say otherwise it's not that it's definitely not needed. Yes, Amanu, Azure has taken generally the strategy they take Azure is that they take for bigger companies and that way. Okay. Any other question? Anyone? Ankit, I'll definitely share the links. Okay. Then wish you all the best, and let's call it a day then. Okay. Bye. Thanks everyone, and wish you all the best for our interviews.